This is StarTalk, Cosmic Queries Edition. Neil deGrasse Tyson here, your personal astrophysicist. And I got Chuck Nice with me, of course.
What's
Chuck,
up,
my
Neil?
faithful co-host. We need you for the Cosmic Queries so that you can mispronounce everyone's name.
Well, that's my purpose in life, Neil. I live to butcher names, you know?
Those poor questioners.
Yeah, so this is one pegged up for you. How would you attack my name?
Oh my goodness. Nick Bostrom, is that what you? Is that how?
It's pretty good.
That's pretty good.
That's all right.
In Swedish, it would be Niklas Bostrom, but that was close.
Okay, all right. And listen, I'll take close. As far as I'm concerned, names are like a game.
Close is better than.
Yeah, that's like a game of horseshoes for me. Close is good enough.
Good enough. So that was indeed Nick Bostrom chiming in. Nick, welcome to StarTalk. Dude, you started something that has got the whole world spinning in a tizzy for birthing the concern that we all live in a simulation. And let me just give a fast bio on you. You're a professor at University of Oxford and in the Future of Humanity Institute.
Oh, that doesn't look very bright.
That's kind of what you know. It doesn't look very
bright. Sorry, Nicholas. Not a lot of job security in that, buddy.
No future for
looking
humanity.
At the future of humanity, yo.
So you think about artificial intelligence, the ethics of artificial intelligence, biosecurity, macro strategy. We'll ask you what that is in a moment. Just policy, ethics, foundational questions about serious challenges that civilization faces, not in the distant future, but in the very near future. I like the fact that you have a background in theoretical physics, so put you in the physics club here, that's good. Also computational neuroscience.
Wow.
We have some of those at my home institution at the American Museum of Natural History. That's quite the frontier as well. And you had a rather influential research paper titled, "Are You Living in a Computer Simulation?" And for me also, I remembered your book, Superintelligence, which all of these got people thinking, as any good philosopher should do, is to get people thinking. And so could you just start us off? Why do you think we might be living in a simulation?
Well, I have this thing called the simulation argument, which doesn't actually prove that we're in a simulation, but it tries to show that at least one of three propositions is true. The simulation argument tries to show that one of three propositions is true. So let's first look at what the conclusion is, and then we can see how we get there. So the conclusion is that either almost all civilizations at our current stage of technological development go extinct before they become technologically mature. So that's like one alternative, right? The second is that amongst civilizations that do become technologically mature, there is a very strong convergence. They all lose interest in creating a certain kind of computer simulation. I call them ancestor simulations. These would be detailed simulations of people with the kind of experiences that their historical forebears had. So that's the second alternative. And then the third alternative is that we are almost certainly living in a computer simulation. So that's the kind of conclusion. Now, how does one get to that? Well, suppose that the first of these alternatives does not obtain, okay? So that means it's not true that almost all civilizations at our stage fail to reach technological maturity. Some non-trivial fraction make it through, okay?
All right.
Then let's suppose that the second alternative is also false. So amongst those who do become technologically mature, some non-trivial fraction remain interested in using some of the resources to create these kinds of ancestor simulations. Then you can show that the kind of computational resources a mature civilization would have would suffice to create millions and billions of detailed simulations, ancestor simulations, runs of human history. And so that if the first two alternatives are false, then there would be many, many more simulated versions of people with our kinds of experiences than there would be original, implemented in a basic physical reality people with our experiences. And conditional on that, if almost all people with our experiences are simulated, we should think we are probably one of the simulated ones rather than one of the rare non-simulated ones. So that means that if you reject the first two alternatives, you would then have to accept the third one. And then that shows that it's not the case that all three of them are false. So hence, at least one of them is true. So that's the structure.
Why can't there be a fourth other truth that no one gives a rat's ass about simulating anything anywhere?
So that's the second, right? I mean, so if all of these technologically mature civilizations are completely uninterested in simulating, then that would be possibility number two. But note that for the second alternative to hold, it's not sufficient that most of them kind of are not very interested, because even if it were just say 1% of these mature civilizations that were even a little bit interested, they still could produce millions of them. And so there would have to be this extremely strong convergence, like almost all of them would completely have to lose any interest in doing this in order for the second alternative to be true.
So I have publicly mildly butchered your line of argument there. So let me first apologize. What I had been noting is that we do not have the power yet to create a perfect simulation of a world such as the one we're living in. And so I wasn't thinking that everyone would make these ancestor simulations, which we would be. And so an ancestor civilization in a cinematic parallel would be a movie about Spartacus or Cleopatra. Just something, a movie, which is modern technology, telling a story set in a time when they didn't have movies, right? So that would be like I'm guessing that's what you mean by an ancestor simulation. And so I was thinking that every simulation would ultimately be able to duplicate themselves as a natural evolutionary arc. If that's the case, then we would either be the original simulation, then we would either be the original universe that hasn't yet simulated anybody yet, or we'd be sort of the last one simulated, still working our way towards the power of simulating ourselves, which would be slightly better odds, well, a lot better odds than throwing a dart and landing in all the simulations that had enough power to create simulations of themselves.
So first of all, I don't claim that the only simulations that might be made are ancestor simulations. I mean that if you imagine your technologically mature civilizations, you might simulate all kinds of things like real histories as close as you can get, fantasy worlds, counterfactual histories, imaginary alien civilizations. I mean, you could, maybe there are like lots of all of these kinds of simulations. The argument focuses on ancestor simulations just because that's the easiest way to get to the conclusion that one of these three is true. But it doesn't imply that there wouldn't be lots of other simulations as well.
Okay, so we have some data with our own history of cinema. And it's some very small percent of movies are set in a time before movies were invented, which I would classify as sort of ancestor storytelling. It's like in the low single digits. So you would say that there's so many movies, even the low single digits is quite a few. And you throw a dart, we could easily be one of those.
Yeah, so I mean, I guess when we extrapolate to these technologically mature, presumably post-human civilizations, well, first of all, I'm not sure how much we can infer from the kinds of movies we create to what types of simulations they would run. But let's suppose, for the sake of the argument, that the majority of simulations they run are of people in their contemporary society. So I don't know, some super advanced space colonizing thing with super intelligences or whatnot, and that's maybe the majority of what they do, but that they assign some smaller fraction of their computational resources to doing these ancestor simulations. Let's assume that. I still don't think that would defeat the simulation argument, or indeed even the alternative that we are in a simulation, because we kind of already know that we are not one of the posthumans. I mean, you just look around, you don't see a lot of sort of starships, whizzing by outside your window, and we are not currently running any simulations ourselves. So we can kind of cross those out. Like all the actual posthumans, we know we're not one of those, and we also know we are not in a simulation of a posthuman, since that's not the world we experience. Then that leaves only the people in original history at the human level of development, and also whatever ancestor simulations are at that level of development. And so my claim would then be that, if the first two alternatives of the simulation argument are false, the simulated ones at our current level of development would still vastly outnumber the original ones at our stage of development.
So what is the likelihood that, not likelihood, because that's the wrong word. Is it possible that it could just be the way that we create with our limited technology what we feel are simulations of our lives, okay? And that's computer games and video games and things like that. Could it be that a civilization so advanced that they have the computational power to create all of this just for the hell of it? Just because, like the same way we do it. We do it for entertainment. Could it just be that? Or is that just not a part of the philosophy?
It could be. I mean, so the simulation argument itself is agnostic as to what the motivation would be of the simulators. And you could indeed imagine many possible motivations. One would be just entertainment, right? And you could imagine other, like maybe some kind of research, like historically, maybe it would be interesting to explore counterfactuals of history, or you could imagine art projects, or you could imagine moral reasons for. I think we know rather little about the psychology and motivations of these hypothetical post-human civilizations and why they would make simulations. And we can speculate about that, but yeah, either of those would work for the simulation argument too.
Okay, so Nick, I guess you're allowed to say all this like from your armchair, but at some point somebody wants to walk into a lab and make a measurement that says, here's the evidence that supports Nick's argument. Is there such a anything we can look for? Is there a sign? Is there some experiment we can conduct to say, yep, we're not in charge of what's happening here. This is a simulation?
There certainly is sort of empirical premises that flow into the simulation argument. And so evidence for or against the truth of those assumptions, would be relevant to evaluating the argument. So one empirical premise is that a technologically mature civilization would indeed have the capability of creating ancestor simulations, and indeed to create lots of them. And so the kinds of evidence that would be relevant for that is evidence, say, of the kinds of computational performance you could get from physically possible systems. We're not able to build them currently, but we can kind of do first principle modeling of different computational systems based on nanotechnology and so forth, and we can place lower bounds on the kind of compute power that they would unlock. So that would be one element that would flow into this. Another would be some estimate of the computational cost of running an ancestor simulation. I think the largest part of that cost is the cost of simulating human brains at a sufficient level of detail that the simulation would be conscious. And we can obviously not precisely determine what the computational expense of simulating a human brain is, but we can place some upper bound on that. We have various views about what computational tasks the human brain is capable of performing. We know how many neurons there are, how many synapses, how often they fire. We can roughly estimate that. Now, it turns out that if you estimate the amount of compute power available, even if you make rather conservative assumptions about that, and then you make conservative assumptions about how much it takes to simulate one human brain, and therefore how much to simulate all of the human brains, you just multiply that by 100 billion or something to all of the human brains in history. There are a number of orders of magnitude gap between these two. So even if you're off a little bit in these estimates, it still seems like the argument holds. But so those would be empirical premises that we could, theoretically obtain evidence against. Like if we discovered the human brain uses some kind of weird quantum computation that is a lot more expensive, then that would flow into it. Then if in addition you want to conclude not just that one of these three alternatives is true, which is all the simulation argument itself says, but if more specifically you want to conclude that we are in a simulation, that the third alternative is true, then there is an additional range of empirical questions that become relevant, like anything that gives you evidence against the first two or in favor of the first two would be then relevant evidence for evaluating the third, right? So if we discover that there is some kind of big risk, some doomsday mechanism that we can, now we realize this, all sufficiently advanced civilizations will stumble on this new technology and destroy themselves, that would be argument against the simulation hypothesis because it would make the first alternative more likely.
Well, that'd be a really sad argument against it because it would say, here's our proof we're not simulated. We're about to destroy ourselves.
We're going to blow everything up. Yeah.
Yeah.
Now, Nick, let me ask you this, Nick. Is it possible that you are so smart that you are constantly high and you don't know it?
Well, I think in some more or less metaphorical sense, I think that's very likely to be true. It's kind of the pessimistic meta-induction, right? So if you look at all humans who have ever been alive, all eras going back in time, we can now see from our current vantage point, basically they were all very wrong about some big thing. I mean, like starting with simple physics, they thought Earth was in the center, and then but basically we can see if we look back more than 100 years, we see that they all got a whole bunch of really core things wrong. And it would kind of maybe be a little bit presumptuous to think that now finally we've gotten all of these basic things right. It seems more likely that if people 1,000 years from now look back at 2021, they will probably also see big, not just gaps in our understanding, but like things we were fundamentally confused about. And so
yeah, they'll laugh their ass off at
Exactly.
everything we're talking about right now.
yeah,
Okay.
or cries their out or whatever. So I do think we are, in a fundamental sense, very much in the dark about the really biggest picture. Still, we do what we try.
We'll take a quick break, and when we come back, we'll transition to our questions that we've solicited from our Patreon members. And Chuck has them all. I haven't seen them. I don't know if you've seen them yet, Nick, either. But he's not here to try to stump us. He's here to just bring the enthusiasm of our audience into the show. So we'll be right back.
I'm going to try to stump you.
Okay. We'll be right back. We're back. StarTalk. I've got the one and the only Nick Bostrom. I generally regarded as the person who birthed all of our sleepless nights wondering whether we are in a simulation, not only from his research papers, but from his books on the subject. And he's a professor at the University of Oxford. And Chuck, what is the name of his thing here? The Future of Humanity Institute, which Chuck and I are pretty sure will be very short-lived.
Yeah, there you
there's
go.
no future for humanity at all. Just before we get to the questions that Chuck has collected, Nick, if it's one thing to simulate all of the brains, I get that. But it's another thing, the fact that I can go into a garden and then look at a flower or dig through the soils and keep digging and reach the mantle of the earth. Whoever's simulating us has to simulate not only what my brain is doing, but it has to simulate all the things my brain is experiencing. And that's not just for me. Someone else could dig that same hole and they should be finding the same thing. So isn't the total complexity of the world, doesn't that have to be part of this simulation? Even the fact that I, as an astrophysicist, look out to the edge of the universe, decoding the nature of the Big Bang and all time and space that followed it. So why just limit your estimates to the power of the human brain if everything and the unfolding of the great cosmic story has to also happen alongside it?
Yeah, I think you do need some computation assigned to simulating relevant parts of the environment. I think the biggest part will be the brains, but certainly if you had to simulate all of the environment at subatomic detail continuously, I mean, like quantum simulation of the entire universe would be completely infeasible if the simulators have anything comparable to the compute power that we could realize in this universe.
You know what? I'm going to disagree. I'm sorry. I know you're a genius, but here's the deal. Here's why I'm going to disagree, Nick. Because when movie makers make movies, they do not render the detail in every single little thing. What they have...
He didn't get there yet.
Exactly, yeah.
That was the next thing he was going to talk about.
That's good. You're
Oh,
ahead
man.
of me.
Now, see, you already thought of this. Like I said, Jesus Christ. Here I am making a discovery, man.
Okay, all right, Chuck. Okay, continue. Wait, Chuck, finish the point, and then we'll pick it up there. Go on.
Well, both of you already knew where I was going. But the deal is this. If you actually create a background, that background will pretty much be the same for all the characters that are mapped onto that background. So that's the way. That's all I was saying.
No, I mean, I think that's the key for to understand this whole simulation argument stuff. That if you had to simulate all of the environment in subatomic detail continuously, it probably would be completely infeasible to do that. But I claim that's not needed. All you would need to do is to simulate enough of the parts that we are observing when we're observing them that to the simulated creatures, it looks real and that they can't tell the difference. And that's a lot less.
All right, wait a minute. I just thought of something else in support.
So what that would mean, Chuck,
Go ahead.
Chuck, what that means, if there are whole sections of the Pacific Ocean where there isn't a boat, right? Then no one has, so it doesn't exist until somebody has to then see it and process it.
Right.
So it's a procedural content generation. So we use it in our computer games today a lot. Like you often only render the parts that some character in the game are observing. And maybe you have some very coarse-grained simulation of the whole thing continuously, but you may fill in details if and when is needed. So if, like right now, I don't have any idea what the atoms in this desk in front of me are doing, right? But if I took, in principle, an electron microscope or something, I could look and I better see atoms there, right? But
the programmer would know you're about to bring out an electron microscope.
Right.
So time to up the calculation right in the beam right there.
Right. And if necessary, I mean, they could even pause the simulation or edit it or erase memories if they really screwed it up. But yeah, I think the kind of the kind of capability you would need to even create anything resembling this kind of simulation is very advanced. And I think with that advanced capability would also come the ability to edit and to monitor human thoughts and intentions, and then kind of be able to do this kind of procedural generation that even we do in our computer games today.
That could explain why I've heard Neil say this, that we are terrible data takers. Like as human beings, we're awful at taking in information. Well, if I'm programming a simulation, I would certainly want to program the people in that simulation to be like that, because that way I wouldn't have to program all this detail into stuff.
It protects
the integrity of my simulation.
Yeah. Although I think, to be fair, I think the difference between one human and another, from the point of view of the simulators, it's like, well, there is one ant. It's got a few more neurons. It's this genius ant, but I mean, we are all like ants, I think. So I don't think the difference in cost is that big.
Cool, very cool.
All right, Chuck, bring on a question. Let's see what you got.
All right, here we go. Let's jump into this. This is Dennis Gislain, and Dennis says this.
Wait, spell that?
Gislain. I said Gislain.
Yeah, it's Gislain.
It's probably Gislain.
Okay.
Gislain.
Gislain. Okay, go on.
Well, then it would be Denis Gislain. Okay. Denis Gislain would like to know.
Okay.
He says,
bring it on.
He says, in his papers, Dr. Bostrom talks about post-human stage civilization. Could you please develop on that and situate it in, Kardashev Scale? Now, I don't know what any of that means.
Okay, I can tell you what the Kardashev scale is.
What is the Kardashev
Yeah,
scale?
when I lead off with that, I'll hand the baton over to you, Nick. So the Kardashev scale is a scale of how much energy you have access to and can exploit. Okay, so I think there are 5 levels. So one of them is, do you have access to all of the energy sources in your host planet? And if you do and you can exploit them, you're civilization level 1. So that means you can go into a volcano and tap the energy. You can tap the volcano the way you tap a cake. You could use the energy in the crust of the earth that would otherwise make earthquakes. You can tap that and use that for your own means. Storm systems, this sort of thing. So a level 2 civilization would control all of the energy that comes from its host star. Okay, so it's way more energy than what is embedded in your planet. Probably. A level 3 civilization would control all the energy of your galaxy that you happen to live in.
So the massive black hole at the center of the galaxy, you could use that.
Yeah, exactly. And you wield this. Okay. And the history of civilization reveals that the nations or the nation states that had the most power, political power, cultural power, were those that actually wielded the most energy per capita in the world at that time. So when people say, United States, we're such energy hogs, we use 4 times, 5 times the energy as anybody else. Well, that correlates with other measures of power that exist in it. So let's keep going. So one more, there's level 4, level 5, if you control all the energy of the universe, and then you're indistinguishable from a god that anyone would have suggested. Now, so what are we? We're digging fossil fuels out of the earth.
Oh.
We don't control any.
We're level 0.5. We're level 0.3.
No, we're level 0. Okay, we're level 0. Okay, so Nick, if there's a super intelligence, presumably they have better access to energy, especially the kind of energy you're talking about that might need this simulation. So have you thought about where a superintelligence might fit on the Kardashev scale?
Yeah, I mean, I think that would be higher up, just because at that level, you would be able to run a lot more of these simulations. Even if there were some simulations run by, I don't know, a Kardashev scale, one civilization, like with the Dyson sphere around their sun, and that's all they did. Once the civilization expands beyond that, they could run billions of times more, and there would be plenty of time for them to expand beyond that. So you could imagine almost all simulations that are being run by civilizations that have reached the limits of whatever space they have to expand into. That would presumably be Kardashev 4 or something, unless the universe is so crowded that each one only manages to get the sort of galactic level volume before it bumps up against its neighbors.
Yeah, that's a good point, because you can only have one galactic Kardashev scale civilization, because anyone else who wants it too bad, we're using all the energy. Right. It's like in the United States right now, there's fights over the Colorado River Basin because it's a water source. That river flows through multiple states, and each state has a pact with the other state how much water they're supposed to use, and there'll be future fights on access to this one source of fresh water. And so that's an interesting point. You can't have a universe filled with high Kardashev level civilizations, because they would implode rapidly, it seems to me.
And what level is Death Star? What level is Death Star on the Kardashev scale?
Oh, well, in Star Wars Episode 7, it controlled the energy of a star. So that would be, I guess, level 2.
That's only level 2. Wow, awesome. Okay, here we go. Yeah. Let's jump right back.
And by the way, in Star Trek, the Borg that's a super intelligence that was cosmic in its influence, and so that would be even higher here.
Right.
Just to put that in context. So Chuck, give me another one. You got another?
Okay, this is William D.A. Quite easy. It's nothing but letters. Here we go. He says, where do you stand on the concept of consciousness, and where do you draw the line? Would a simulated reality change your definition of what possesses consciousness?
I like that. So, Nick, is panpsychism, I presume that means that somehow consciousness is a shared entity that we all participate in as one
Panpsychism,
organism?
I mean, there are different sort of definitions, but it's broadly the view that everything is conscious.
Oh wow.
I don't.
And so how do you put consciousness in? Is that a natural outflow of a sufficiently complex computer simulation of the brain?
That would be my sort of default assumption. Yeah. I mean, I think for the simulation argument, you can kind of plug in whatever your favorite theory of consciousness is, and most of them would work. There might be some theories of consciousness which would not work. The simulation argument, one of its assumptions is what I call the substrate independence thesis, which is just the idea that in principle, you could implement consciousness not just on carbon-based biological structures, but on any suitable computational structure. That what makes us conscious is not that we're made of carbon, but that our brains perform a certain type of computation.
Whoa.
Now,
Holy crap. Wait a minute.
Yeah,
So,
Max Tegmark has
I was
written
about
on
to
that
say.
very subject. He's
yeah,
a
your
good friend
buddy
of
Max.
StarTalks. Yeah.
And his thing is like
yeah.
the entire universe is made of math because it goes down to particles, and these particles have spin, and so you can assign a value to them.
Mathematically constructed entities.
Yeah.
Yeah, there's good overlap there. Yeah, okay.
But as to where to draw the line, like I don't really have a very good account of exactly. So I mean, I think humans are conscious and rocks are not conscious, but like exactly where, sort of in the hierarchy, there would be a cutoff. I'm not sure, or I'm not sure either that there is a sharp line there. It might more be that there is kind of diminishing, or more and more strained senses in which lower order organisms have some kind of consciousness, and it kind of fades out rather than there being a sharp threshold, is what I would guess. But
so here's what I wonder, Nick. I just have a not deeply thought out hypothesis that having thoughts such as we do that are incomplete, and we wander and we don't have good memory of things, or we make stuff up, the fact that it's not perfect, we interpret as consciousness. Because if it were perfect, it's just data, and our brain is a storage disk that occasionally puts information together with a new result. But the fact that we can sit there and say, oh, I feel this, and I don't, and it's mostly how we reckon with our ignorance of our environment, even when we probe it for knowledge. I'm just putting it out there.
yeah, well, I mean, I guess first of all, you could have, a lot of artificial, even simple systems that would be imperfect in various ways. You could have some faulty hard drives that randomly erase various things. You could also have kind of compressed representations. That's what you have to do if you're trying to do anything with AI. Is there's a lot of data coming in, and you have to extract some important features based on that and throw the rest away. So these things.
Wait, Chuck. What Nick just said, I can't stop thinking about it. So Chuck, every time you and I forget something,
Right.
the alien's hard drive messed up.
Exactly. So every time you go, what did I come upstairs for?
It's a read write error, an I/O error in the programmer's disk.
Well, so
That's
I don't think
and
so.
we think this is
it's
consciousness.
like a fun idea, but no, I was just exploring your account of consciousness. That somehow what's necessary or sufficient for consciousness is that there is some kind of faulty or limited information processing.
Right. Otherwise, it's a perfect computer.
Well, I'm saying that computers are also imperfect in certain ways, and I'm not sure that the closer you get to perfection that you would lose consciousness. I think in anything it might go the other way around, that you might become more conscious if you were more. But yeah, you might have to, if you wanted to sort of elaborate on that, you might want to try to say like which types of imperfection are the ones that are supposedly making a system conscious, and maybe exploring that line of thought further, maybe you would get to something that would be some kind of plausible account of consciousness. I'm not sure.
Oh,
Yeah,
wow.
in the film I, Robot, forgive me for not having read the original series of short stories, but by Isaac Asimov. But in the film, they hypothesize what could account for free will in a programmed robot, and they were describing how many generations of operating systems are layered on top of one another, and there's always these dangling parts that you don't always clean it up after, because evolution is like this too. They're dangling parts that worked at some point, now you don't need them, or that they could get in the way, or they can end up killing you. But programmatically, there could be lines of code that have long lost their utility, but could manifest under certain combinations of stimuli that look like the robot just thought of a new idea. And I was intrigued by that suggestion when I heard it in the film, that could be the way you end up with what we call consciousness. But anyway, we got to take another break. When we come back for the third and final segment, we're going to go through a lightning round with our questions, and it's Nick Bostrom just schooling us on whether or not we're in a simulation. And spoiler alert, it sounds like we kind of are. It sounds like, yeah. Okay, when StarTalk returns. We're back, StarTalk. I've got Nick Bostrom in the house. Actually, he's in the UK right now, but he's in our Zoom house, and we're talking about the simulation hypothesis, and which he's largely started. Okay, and so we blame him for all of our lost sleep at night. Nick, I blame you if no one else does. So Nick, the simulation hypothesis requires that every simulation has computers, right? Well, why is that an obvious thing? In fact, we've only had computers for like half a century, and we've been human for a couple 100,000 years in our current form. Why should it be inevitable that a computer is the thing that gets invented that then people want to simulate on?
I mean, I don't know that this is inevitable. Maybe if there are a lot of humanoid species that never developed computers, I don't know. I mean, it suffices that some civilizations do develop computers, and then more advanced computers of the type we can already see are physically possible, although we cannot build. But certainly it's consistent with a lot of civilizations failing to reach even our stage of development. I mean, I think if you're asking about inevitability, even if it's not relevant for the simulation argument, it's kind of interesting. Like you want to, I guess, define what point in time, if it's inevitable, like it seems like the farther back you go, if you sort of reran evolution from that point, the less likely that you would get something similar to what we have today. If you started with just bacteria, like, and who knows, maybe the chances would be very small, perhaps, that you would get an intelligent technological species. But if you started like 50,000 years ago, then, I mean, my guess would be we were already pretty well on the way, and it was just a matter of time.
Oh, that's an interesting point. Okay. Because the contingencies of evolution, right, it would take, in fact, if the asteroid didn't hit 65 million years ago, the dinosaurs would be here and we wouldn't, for sure. They having
this conversation. They'd be here,
a slightly bigger brain.
Yes, exactly.
But rather than that proverbial walnut-sized brain that they had. But clearly, they would still be here, they having been around for several 100 million years before the asteroid. So, but yeah, you take it late enough, Nick, that's a good argument. Start at 50 or 100,000 years ago. I'm good with that. We surely, there'd be some evolutionary path. And just for those who are ET fans, consider that we all would judge the Roman Empire to be an intelligent civilization, yet aliens trying to communicate with them with radio waves would conclude that there's no technology on Earth, right? So we spent a lot of time being smart, but without the technology. And so that's the real question. How much longer do we have technology before we exterminate ourselves? But anyhow, Chuck, this is Cosmic Queries. Bring it on.
Okay.
And Nick, we're going to try to bang out a whole lot in this third and final segment. So let's try to keep the answers tight. Okay.
All right, bring it on.
All right, this is Dylan and Gordon Vu. Going to mash up their questions. Hello, everyone from Albuquerque, New Mexico. I'm a senior in high school, and this question has been bugging me forever. Do we have free will, or is everything set in stone? Are we living a predetermined life if we are in a simulation? And then Gordon Vu says on top of that, if we manage to prove that we are living in a simulation, does that mean there is or is not a God? Thank you. Wow, talk about some philosophical, big gun questions.
Theological, philosophical. So, Nick, I love those questions. What do you have to say about it?
Yeah, well, I mean, on the latter, I think it wouldn't prove or disprove God. I think it's an independent question, whether we are in a simulation versus whether God exists. So I don't see any necessary connection there. On the free will, I think we would have as much free will in the simulation as we would without the simulation. I'm a compatibilist myself, so I think that even if we are living in a deterministic physical universe, that would be consistent with us having, in the relevant sense, free will. But you might have a different view on the metaphysics of free will, but I don't think the fact that we would be in a simulation would necessarily change that.
Well, but would that mean that the programmers of that simulation would program into our brains a perception of free will, even if they know the outcome in advance at every moment?
I don't think they would need to especially program that in. I mean, for the same reasons, if we are not in a simulation, would have this notion of free will. The people in the simulation would presumably develop that for the same kind of reasons. I mean, it connects obviously to holding people accountable for certain things they do. I mean, if you stumble into somebody and bump them, we say, well, you're excused because you didn't intend it. But if you go and punch them and achieve the same bruise, then you will be held accountable because that's something you did of your own free will. And we make choices that we have to actually internally come up on a certain decision. So all of those things would hold equally true for people in a simulation as people outside a simulation, right? So if you have this view of free will, there wouldn't really be a difference, I think.
All right.
Interesting. Okay.
All right, Chuck, give me some more. And Nick, you're doing great with the short answers. Good. Okay. Oh, wait. Let me go back to the God one. Wait, so why can't just the programmers be indistinguishable from God if they have power over everything?
Yeah. I mean, depending on what you bake into the concept of a God, yeah, in many ways that would be analogous to how some people have traditionally conceived of God, right? In the sense that they would kind of have created our world, although they wouldn't have created the whole world, just the parts that we see. They would presumably maybe not be omniscient, but they would know a lot. Like they could sort of see everything that is going on inside our simulation, and they would not be omnipotent. They would themselves be subject to the physical constraints operating at their level of reality, but they could intervene in our reality, including in ways that contravene the laws of physics that we perceive. But so in one sense,
and thereby produce miracles, and that would be a miracle.
But things that appear to us in the simulation as miracles. So in one sense, there is the kind of structurally similar relationship. On the other hand, they would be subject to all these, they would presumably be finite and subject to all these kind of limitations and constraints. And in that sense, kind of being infinitely far removed from a lot of the traditional conceptions of God, which is like a literally infinite and omnipotent and omniscient being. So I think that whatever the truth is about the simulation hypothesis, it wouldn't settle the question of whether there is this kind of more traditionally conceived, literally infinite God.
Okay.
Got it. Perfect.
There you go.
Okay, Chuck, keep it going.
Frederick Johansson wants to know, is general AI really a question about hardware and processing speed? If it was, wouldn't a computer today be able to simulate a few seconds of AI like it had 1,000 years to process?
Yeah, I mean, it's a good question. I think compute is a very important factor in driving AI progress over the last 8 years or so with the whole deep learning revolution. I think it's maybe 2/3 of the progress we've seen is due to we are applying more compute, and then maybe 1/3 is algorithmic progress. It's not, even if it were all
compute, though, it doesn't necessarily follow that we would be able to, with our current compute, run at least a small fraction of a human level mind, because there are two things you need the compute for. So one is to run the AI, right? Like to actually have it do, but you also need to train up the neural network that becomes the AI. So if you don't have enough compute to do the full training run, you might not even be able to develop the system, which then, if run, would constitute some kind of human equivalent level AGI.
Right, because the calculation or the decision is not made in a vacuum. It's been completely preloaded with the world's life experience or whatever is sitting right behind that one decision. Is that a fair way to think about this?
Well, so for humans to arrive at some sort of normal adult level of performance, we need 20 years or 15 years to kind of grow up and learn. And our current neural networks are similar in that, although they're probably less efficient in learning. So they might need, instead of 15 years of experience, maybe they need like 1,000 years equivalence, although you can run it faster on them. But you still need a lot of compute just to be able to complete something analogous to like a human maturation process. So even if we had enough compute to run an AGI, a human level AI, we might not have enough compute to sort of create it. I think also, though, in addition to more compute, we also need some additional algorithmic insights. But it's not all or nothing. Like the better the algorithms, the less compute you need to achieve this result. And right now, the amount of compute you need would be like way more than we can currently afford. And then it comes down as we make algorithmic progress at the same time as our computers become faster. And at some point, these lines will intersect.
You just made a point embarrassingly clear that humans require like a fourth of our lives just to function as participating humans in civilization. That's embarrassing, but true, right? Right. No one trusts your decisions you make until you're at least 20. And even then, for some people, never.
Yeah, I mean,
the brains are really not working even after. Right.
As a kind of collective, we have just kind of barely enough intelligence to be able to create a technological civilization. I think we look like we're right on the cusp of that. And it's not so surprising, maybe, because like if you imagine our ancestors had a lot less abstract reasoning ability, and it gradually improved over biological timescales, right? And then as soon as we became capable of creating a technological civilization, then we pretty much did it, or after 10,000 years or something. So we should kind of maybe expect that we are at the lower end of what is needed to do this at all. And that maybe explains some of what we see in the world, that we're kind of fumbling our way.
A lot of what we see in the world, yeah. Yes. All right, Chuck, give me more. You got a few minutes left.
Skylar Gravatt says, if this is a simulation, why are the people running the simulation so patient? The universe is estimated to be 13-point-something billion years old, and they waited almost 10 billion years to simulate life.
So first, there's no particular reason to think that those 10 million years were simulated. They could just have picked up at a later point, right? You don't need to do it from the Big Bang onwards. You could start the simulation from a later point.
Wait, you'd embed the simulation with evidence that simulation scientist would then interpret as an old universe. But it's all just fake.
Yeah,
is what you're saying.
You probably don't want to sit through like 10 billion years of just gas clouds congealing. Like that would be a pretty wasteful use of
kind of boring, right? Yeah.
Yeah. But even when you get into the say they were interested like in all of human history, for the sake of the argument, that's the 10,000 years ago onward. Like, it doesn't mean that for them it would take 10,000 years to do this. They could run the simulation at a higher speed, like maybe 1 minute of their time could simulate 1,000 years. It depends on how fast the computer is that you run the simulation on.
Right. So when we had a great revelation when computing power was adopted by astrophysicists in the 1970s, we were early out of the box on this. There were these galaxies in the universe that were kind of funky looking, and we made catalogs called peculiar galaxies. We didn't, maybe we just thought galaxies were made that way. Only after we were able to simulate the collision of two galaxies, did we realize that this is like the crash scene leftovers of what happens when galaxies collide, and we simulate 1 billion years in a matter of minutes. And in so doing, we were able to populate the entire catalog of galaxy parts and nasty, twisted-looking galaxy forms simply by seeing what happens when they collide and speeding up the time to do so. That's just a little aside. I thought.
Wow. What are you prescient or what? This is Nathaniel Mitchell, who says if we could ever simulate an exact replica of our universe down to the spin on the components of quantum particles, could we speed it up and then use it to predict our future, as we now do with simulations for climate and otherwise, but yet on a cosmic scale?
Well, so that kind of thing wouldn't fit into our universe, like a computer that simulated all of our universe. It wouldn't be possible to build that in our universe.
Oh, so that's a philosophical challenge. That's like saying,
well, yeah, I mean, it's
how
also
detailed do you want your map to be?
Right.
If you have a map the size of the UK, then it'd have all the detail of the actual island, but then you could just use the island.
Right.
The map is
Yeah,
no longer useful to you.
Be like that.
Right.
So you, yeah, I mean, so, and yeah, I think it would be very infeasible to simulate our world at the level of, quantum properties. At least if the simulator's universe looked anything like our universe. But maybe the physics at their level of reality is different. I mean, maybe they have maybe it's possible to build more powerful computers. You could even imagine hypercomputation being possible in some other kind of physics, so that they could run literally infinite computations. And then maybe they could simulate a world like ours at full quantum detail. But
then run it forward and watch the future evolution.
But I mean, from our point of view, it would presumably not make much difference whether they did it that way or the much cheaper way that would only render things at a sufficient level to be convincing to the people inside. And in fact, even if you imagine that there were some simulators that could do this at full quantum detail, it would cost them so much more compute that it would still likely be the case that almost all simulations would run in the more efficient way that would only simulate things at the coarser grain. So even if there were some full-grained simulations, we would probably be in one of the other ones, because that would be a lot cheaper, and so you could create orders of magnitude more of them.
And how much of this relates to the fact that it's hard for something to understand itself? Like, can the human brain actually come to understand the human brain? Is that, or do you need a higher intelligence than the human brain to then study the human brain as a thing outside of itself?
I mean, understanding is a matter of degree, right? So we know some things about ourselves, and obviously there's a lot that we don't know. And so we understand a bit about ourselves now. We could understand more. I mean, obviously you couldn't have a full simulation of all the details in the human brain stowed away in a part of the human brain, right?
I guess that's the question.
That's the map of the UK. That would be as big as the UK, if you wanted all the details.
Right.
I've been to paradise, but I've never been to me.
Chuck. Thank you, Chuck. So we got to land this plane. Let me just offer my best evidence for why I think we live in a simulation. I'm just going to go public on this. I think right when civilization is kind of going smooth, then something happens. Okay, a politician rises up, there's a war, there's a world war, there's tsunamis, and I think the aliens program that in for their own entertainment. Because that's what we did in the sim games. In Sim City, where you're mayor of a city and everything's going fine, unannounced, Godzilla trounces through your city, and now you have to deal with it, the fire and the police and to rebuild the schools, and that's you running the software. The programmer sending that in without telling you that's going to happen. I think all of the troubles we have in the world is evidence that the programmers need entertainment. Yeah, well, Nick, like I said, we got to land this plane. Thank you for coming out to StarTalk. This conversation was long overdue. I wanted to get you a few years ago, but you were in high demand, and you still are, for sure. But if any of us discover something like we part the curtain and we see like a CPU there that when it was supposed to be a couch, I'll call you up.
Well, if anybody viewing that does that, contact Neil rather than me. I don't know.
For sure. All right, it's been a delight, Nick. And is the Superintelligence the book you would have people sort of check out in terms of the foundations of this thinking?
Yeah, well, I mean, not specifically on the simulation argument. There, the article is online. Just Google it, simulation argument, you'll find it. But if you want to read a book about the future of AI and stuff, then Superintelligence would be the one I would point to.
Excellent, excellent. All right, good. And Chuck, we can find you at Chuck Nice Comic on Twitter.
Thank you, sir, and everywhere else, yes.
Social media. Excellent. All right, Nick, again, thanks for joining us.
I'm glad we could do it. Finally, yeah.
Yeah, finally, this Cosmic Queries episode. I'm Neil deGrasse Tyson, your personal astrophysicist. As always, keep looking up.